Welcome to the deep dive. Today, we're plunging headfirst into artificial intelligence. It feels like it's everywhere, constantly reshaping things, but actually grasping what it can really do and, how to genuinely use its power, well, that remains a huge challenge, even for those of us trying to keep up. So today, we're aiming to go beyond just the headlines. Our mission, basically drawing from a whole stack of expert sources, is to explore what AI can do, how it's already guiding decisions, and maybe most importantly, how you can actually leverage it. Think of this as your shortcut, maybe, to really getting AI, separating the real stuff from the hype.
Exactly. And, here's the thing that might surprise you. AI feels so new, like tomorrow's tech. But the basic ideas, they've actually been around for a surprisingly long time. And understanding that history, that context, it's kind of key. It helps you see why things are happening now and, crucially, where the limits still are. That's your edge, really.
Right. Okay. So let's cut through the buzz then. Practically speaking, what is AI? What are the basic mechanics, and how did we get here from those older ideas?
Okay, so in essence, you can kind of break AI down into two main types, fundamentally. First, there's what we call symbolic AI. This is the older approach. Here, human experts literally write down all the rules, sometimes thousands of them, maybe in a program or even a huge Excel file. Think like early credit scoring systems. IF score is X and ND income is Y, then approved. Every single step is mapped out by a person. The computer just follows instructions. Then the second type, the one making all the noise today, is machine learning AI. Here, the algorithms don't just follow rules someone wrote, they actually learn the rules themselves, or, well, scientists will call them mathematical functions. But basically, it's the prediction logic. They learn it straight from data, lots of data. So a modern credit system, you wouldn't tell it the rules. You'd feed it tons of past customer data, who paid back, who defaulted. And it finds the patterns to predict who's risking the future. But importantly, both types, deep down, they end up being these mathematical engines, these functions.
That makes sense. Symbolic versus machine learning, rule-based versus rule learning.
Wow.
Okay, but then the thing that's really exploded recently is generative AI. Is that just like a super-powered version of machine learning or something else entirely?
Yeah, great question. And honestly, for scientists, the line between generative and, say, predictive AI can get pretty blurry. Generative AI is definitely a type of machine learning AI. Fundamentally, it's similar. Both learn from data, both predict an output from an input. The unique thing about generative AI is, well, it generates new stuff, text, images, code, you name it. It does this, for text anyway, kind of word by word, or pixel by pixel for images. It's basically just predicting the next most likely bit based on what came before, starting from your prompt. So yeah, it's still prediction at its core, but those predictions build up into something new. And this recent surge, this boom in generative AI, it really boils down to two key technical breakthroughs. First one is embeddings. Okay, try to picture this. Every word, or maybe token is the better term, it gets a unique address, which it coordinates in a giant map. But it's not just any address, it's a string of numbers, maybe tens, maybe thousands. And here's the magic. Words with similar meanings. They get addresses that are close together on this map. That's how you get that famous example. King minus man plus woman equals queen. The math works because the addresses, these vectors, capture meaning. It's how the AI understands relationships between words, not just the letters. The second big innovation is transformers. Think of these as the architectural blueprints for the AI's brain that processes those embeddings. They're specifically designed to look at how words relate across whole sentences, even paragraphs, not just the word next door. This lets them grasp context, nuance, long-range dependencies, stuff older AI really struggled with. That was a massive leap for understanding and generating language.
Wow, okay, that really helps clarify things. Embeddings as maps of meaning, transformers as the engine processing them. It sounds incredibly powerful, almost limitless in predicting, even creating. But, every powerful tool has its issues, right? Its blind spots. Where does AI, even with all this pattern finding ability, kind of fall short?
Absolutely, that's the crucial flip side. And AI's understanding, its worldview, is completely, utterly limited by the data you feed it. Nothing more. There's this great online demo, the teachable machine. You can try it. Train an AI only on pictures of your hand, showing 1 finger or 5 fingers. Then show it 2 fingers, or 3 or 4. It'll confidently say it's either a 1 or a 5. Why? Because 2, 3, and 4 just don't exist in the world it learned from. And you see this in other ways, too. There's this, maybe it's an urban legend, maybe not, called tank or no tank. Yeah. The truth is, researchers tried training an AI to spot tanks in photos. It got really good, even spotting hidden ones. But the catch was, it wasn't learning what a tank looked like. It learned that photos with tanks happen to be taken in the morning sun and photos without tanks in the afternoon sun. Different shadows. So it found a pattern, a strong classifier, yeah, but not the intended one. It just latched onto a difference in the data. And this connects directly to bias, right? If your historical data has biases like Amazon's hiring data, apparently favoring men for tech roles, historically the AI learns that bias.
It just reflects the patterns, good or bad, that are in the data you give it. In a way, it's brutally honest about the data's flaws.
That tank story is amazing. It really highlights how differently AI sees things compared to us. Like, it's finding shortcuts we wouldn't even think of. But okay, beyond just learning unintended patterns from the data, I've also heard AI can be, like, deliberately tricked. How does that work?
Right, that brings us to what are called adversarial attacks. These are fascinating and, frankly, a bit scary. You can make tiny changes to an input changes completely invisible to a human eye. Add just a little bit of calculated noise, and suddenly, a deep learning algorithm gets totally fooled. That image of a panda. With near 100% certainty, the AI now says it's a given, or a stop sign. Add some specific, almost invisible graffiti, and a self-driving car might read it as a 45-mile-per-hour speed limit sign. The danger is obvious. These aren't mistakes humans would make, but they can cause serious, real-world problems. Think autonomous vehicles or facial recognition. People have even designed special glasses that can fool facial recognition, letting someone impersonate another person. And what's really concerning is something called black box attacks. The attacker doesn't even need to know the AI's inner workings. They just fiddle with inputs and watch the outputs. And sometimes an attack designed for one AI model surprisingly works on others too, makes the threat much wider. So all of this really underscores a super important distinction. AI is amazing at spotting correlation, finding patterns where things happen together. But it usually tells you absolutely nothing about causation, why one thing causes another.
Okay, correlation versus causation. That's fundamental, isn't it? Can you give us a simple example?
Sure, the classic one is ice cream sales and sunburn cases. If you plot them, they probably correlate really well. When ice cream sales go up, sunburn cases go up too. But obviously, eating ice cream doesn't cause sunburn, and getting sunburn doesn't make you eat ice cream. There's a hidden factor, right? Hot, sunny weather causes both. AI is great at seeing the first link, the correlation, but terrible at seeing the underlying cause. Now, the interesting question becomes, when's it okay to actually act based just on correlation? You can think of it like making a bet. You weigh how strong the correlation is, how confident you are against the cost of being wrong versus the benefit of being right. Like in New York City, they apparently use sensors in sewers to detect high levels of grease, trying to spot unlicensed restaurants dumping illegally. The correlation might be pretty weak. High grease doesn't always mean an illegal operation, but the cost of checking, just sending an inspector, it's low. So they act on that weaker correlation. It's worth the bet. But contrast that with, say, PSA blood tests for prostate cancer. The correlation between high PSA levels and actual cancer is, well, not super strong. There are many false positives. If a high PSA test automatically led to, say, invasive surgery, the risk, the cost of being wrong, is massive. So acting on that relatively weak correlation is not acceptable. The stakes are too high.
Right, the stakes totally change the calculation. So if AI gives us predictions, correlations, but not the why, not the cause, how do we figure that out? How do we know if an intervention, like a new policy or a marketing campaign, actually causes the change we see? How do we make truly informed decisions?
That's where we need something more rigorous. And the gold standard for establishing causation is the randomized control trial, or RCT. You probably know it as A/B testing, especially online, or maybe field experiments in social sciences. The core idea is beautifully simple, actually. You take your group people, users, whatever, and you randomly assign them to two subgroups. One gets the treatment you're testing, the new web page, the drug, the policy. The other, the control group, doesn't, or gets the old version, or placebo. That randomization is the magic key. It ensures that, on average, the only systematic difference between the two groups is the treatment itself. Everything else, age, gender, motivation, whatever, should be balanced out by the random assignment. So if you then see a difference in outcomes between the groups, you can be pretty confident it was caused by the treatment. And businesses use these constantly, often without calling them RCTs. Netflix testing different thumbnail images for a movie, that's an RCT. They randomly show users different images for the short game, I think it was. They measure the take rate, how many people click play and find one image, works much better. That's causal evidence. Pandora, the music service, ran a huge experiment. Millions of users. They varied how many ads people heard to see how it affected listening time. Found more ads meant less listening, cause and effect.
There was even a big study at a large Chinese travel agency, C-Trip. They randomly assigned call center workers to either work from home or stay in the office. Found working from home caused a 13% productivity boost and cut attrition rates in half. That's powerful causal insight from an RCT.
Okay, yeah, RCTs sound incredibly powerful, the gold standard, he said. So if they're so great, why isn't every decision made this way? Why aren't companies running RCTs for absolutely everything? There must be catches, right? Hurdles.
Oh, absolutely. You'd think it would be standard practice, but running good RCTs can be really challenging in the real world. First off, you've got statistical challenges. You need enough people or units in your trial, a large enough sample size. And critically, what is the unit you're randomizing? If you're testing a new sales incentive, are you randomizing individual salespeople? Or maybe whole teams? Or whole offices? Randomizing offices gives you way fewer units, so you need a much bigger effect to detect it reliably. Thankfully, there are tons of online calculators now. You plug in how big a difference you expect to see, how much variation there normally is, and it tells you roughly how many participants you need in each group. Then there are, let's call them, political challenges. What if the experiment's results go against what senior management wants or believes? You really need buy-in beforehand that everyone will abide by the results, otherwise it's pointless. Treatment deprivation can be an issue too. If the treatment is something desirable, like that work-from-home trial, the people stuck in the office, the control group might get demoralized just knowing others got the perk. That itself can skew the results. And finally, there are psychological challenges. The classic Hawthorne effect. Just knowing you're in an experiment can make people behave differently. That's why medical trials use placebos, right? To make sure the effect isn't just from the idea of getting treated. But what's really neat is, even if you can't run a perfect full-blown RCT, there are clever ways to try to get close to causal insights using data you already have. Observational data. One way is looking for unintended experiments or natural experiments. Sometimes randomization happens by chance or for other reasons, like maybe a business school formed project teams randomly based on, say, nationality quotas. That might accidentally create an experiment to study team diversity's impact. Or that South Korean company you mentioned, rolling out a new pay scheme alphabetically. That created essentially random groups over time. You can analyze that like an RCT. Another technique is matching. You try to artificially create a control group after the fact from your existing data. So you take someone who got the treatment, maybe a smoker in a health study, and you find someone who didn't get it, a non-smoker who looks almost identical on paper. Same age, gender, maybe similar health background, income, education, as many factors as you can measure. You try to match them. The big limitation, though, is you can only match on things you actually measured. Hidden differences might still exist. Then there's differences in differences. This is clever. You need two groups that were trending similarly over time before any intervention. Then one group gets the treatment, like a new law passes in one state, but not a neighboring one. You look at how much the outcome changed in the treatment group compared to how much it changed in the control group over the same period. The difference of the differences. For example, comparing COVID cases in country A versus country B after country B starts vaccinating, assuming their trends were parallel before. It relies on that assumption holding true. And one more, gamification or simulation. If you can't run the experiment in the real high-stakes environment, you create a simplified toy version.
Like, researchers wanted to study self-organizing teams versus leader-led teams for novel tasks. They couldn't easily restructure real company teams, so they had groups build things with Meccano sets in a lab and an RCT in a controlled game. The big question mark there, of course, is do the results in the toy version actually transfer over to the complexities of the real world? Sometimes yes, sometimes no.
That's a really useful toolkit. RCTs as the ideal, but then matching, diff and diff, natural experiments, even simulations as ways to get closer to understanding cause and effect. Okay, so let's shift gears slightly. We understand the what's of AI, its limits, how to test interventions. Now, where the rubber meets the road. How do businesses actually take AI and, use it to create real value, change how they operate?
Right. So broadly speaking, you see AI creating business value in sort of three main buckets. First is embedding AI into products and services. Think optimized online ads, health apps doing pre-diagnosis, or entirely new AI-powered features or even whole new products. Second is using AI for optimizing internal business processes, better inventory management, predicting what equipment needs maintenance to prevent failures like in energy grids, standard efficiency stuff, but supercharged by AI. But the third bucket is maybe the most interesting and very AI-specific, augmenting human jobs. This really reframes AI not just as artificial intelligence, but as augmented intelligence, helping humans do their jobs better. It brings to mind Kasparov's law, sometimes called the missing middle. Garry Kasparov, the chess champion, after losing to Deep Blue, observed something fascinating. He found that often a weak human augmented with a machine in a good process to combine the two could actually beat either a strong human alone or a powerful machine alone. The human-machine team was best. And we see this playing out. There was a study, I think, with salespeople selling customized products. They had an AI running in the background, suggesting prices. This AI assistant significantly boosted profits for all the salespeople, whether they were already top performers or average ones. It augmented their skills. It wasn't about replacement, it was enhancement. The autopilot analogy works well here. The value isn't just having a pilot or an autopilot. It's the process of combining them. The pilot handles tricky takeoffs and landings. The machine handles the long, stable cruise. It's that intelligent partnership.
That idea of augmented intelligence, Kasparov's law, that feels really profound. It shifts the whole narrative from robots taking jobs to humans plus AI doing new things. So if a company, maybe a more traditional one, wants to become truly data and AI driven, what does that transformation actually involve? It sounds like way more than just buying some software.
Oh, absolutely. It is not a silver bullet. It's a deep, complex organizational shift. There's this saying, kind of cynical but true. Technology investments plus an old organization equals an expensive old organization. Or, if you don't change how you work, how you make decisions, the tech alone won't do much. Organizational change is absolutely paramount. E.ON, the big European energy company, went through a massive transformation like this. Their journey really highlights the key ingredients. First, top-level sponsorship, absolutely critical. The CEO, the COO, they need to champion it, especially because many AI projects don't have an obvious immediate ROI. Second, talent. They had to bring in new skills, chief data officers, data scientists, engineers, but also massively upskill their existing workforce. Training across the board. They also focused on quick wins. You need to show value early on. Find projects where the data is decent, the impact is high, and you can get something working fast to build momentum and belief, which ties into data evangelization. You have to constantly communicate the successes, tell the story, hold events, make the value visible across the whole company, get people excited. Then there's organizational structure. They used to mix some centralized data teams for big platform stuff, but also decentralized hubs embedded in business units. And maybe the most critical yet unglamorous part, data governance and quality. Data is the fuel, right? The new oil or food for AI. If it's garbage, AI won't help. So massive effort on standardizing data, integrating it, ensuring people trust it. They even tagged every data point with an owner. And of course, handling privacy, security, GDPR. It's huge. Finally, clear investment processes. How do you decide which AI projects to fund? They use gated processes, start small with a proof of concept, then maybe a pilot, then scale up if it works, and acknowledging that sometimes direct ROI is hard to pin down early. You might need to think about option value, how this investment unlocks future possibilities. But ideally, you try to link it to the simplest unit of business decision, like the predicted value of targeting this specific customer with this specific promotion.
That's a really comprehensive picture. Top-level support, talent, quick wins, evangelism, structured data quality, investment process. It's a whole ecosystem, isn't it? Okay, shifting to the how of building these AI models, especially if a company maybe doesn't have a huge internal team, maybe they're looking to outsource or partner. What are smart ways to approach the actual AI development?
Yeah, one really powerful concept here is the team of machines. The idea is simple. Just like with people, a single AI model is rarely the best at everything. Building a team of different, diverse, but still competent models and then combining their predictions almost always gives you better accuracy. This was the big lesson from the Netflix prize competition years ago. The winning solutions weren't single elegant algorithms. They were complex blends of many different models. So how do you get this diversity in your machine team? Two main ways. First is algorithmic diversity. Use different types of algorithms on the same data, maybe a logistic regression, some decision trees, a neural network. They all think differently. Second is data diversity. You use the same algorithm, but you train copies of it on different slices or variations of your data. Maybe one copy sees only a random subset of features, columns. Maybe another sees only a random sample of examples, rows. Actually, a very popular technique called random forest does exactly this. It builds hundreds of decision trees, each on a randomized bootstrap sample of the data, and considering only a random subset of features at each split.
It's often a really good starting point, a strong benchmark, because it inherently combines these diversity ideas and is easy to run in parallel. Now, for outsourcing, a really interesting approach is using AI competitions like on platforms Kaggle or others. The benefits for the company hosting the competition are pretty compelling. You can test out really novel ideas like, can AI identify individual whales from aerial photos? That's hard even for humans. The cost can be much lower than hiring a dedicated team. You're paying prize money, often less than a data scientist's salary, for a working solution. Risk is lower too. You only pay if someone actually solves your problem to your satisfaction. Plus, it's great for networking, finding talented people you might want to hire later. And you leverage this massive global pool of brainpower. You get tons of different approaches tried out by a humongous number of people, often ways your internal team might never have considered.
Wow, yeah. Competitions sound like a clever way to crowdsource innovation, reduce risk, and find talent. But are there pitfalls? You mentioned needing good data earlier. What else does a company need to do to run a successful competition? And you also hinted at a downside to these complex combined models.
Absolutely. Running a good competition takes care. You definitely need high-quality representative data. There was a soil detection competition that kind of failed because the training data was incomplete. It was missing some of the soil types participants needed to identify. You also need super clear rules and goals. A city wanted AI to map where children live for healthcare planning, but they didn't specify how to draw the map regions. People submitted weird, unhelpful, long, thin strips instead of aligning with roads or neighborhoods. Clarity is key. Contests also need to be crack-proof. Can people cheat? One traffic prediction contest was flawed because the prediction period was actually in the past, so contestants could just Google the real future traffic data. And finally, yeah, advertise it widely. The more diverse minds you attract, the better your chances of a breakthrough solution. And yes, the downside you mentioned. These winning solutions, these complex ensembles or teams of machines, often end up being black box models. They work, they're accurate, but it's really hard, sometimes impossible, to understand why they make a specific prediction. That lack of interpretability can be a real problem, depending on the application. Integrating that black box can be tough too.
Right, the accuracy versus interpretability trade-off, that seems like a recurring theme. Which brings us, I think, to a really crucial question for everyone listening. With all this potential, all these tools, these complexities, these risks, what kinds of skills do people, individuals, teams, leaders actually need to develop to, thrive in this AI-driven world?
It's definitely a broad mix, not just deep tech skills. First, just understanding the art of the possible. Being able to realistically assess what AI can and can't do today, separating the hype from reality, learning from what other industries are doing. Then, crucially, managing the risks, understanding bias, how to mitigate it, guarding against deepfakes, misinformation, thinking about new liability issues, cybersecurity threats specific to AI. How do you put guardrails around these systems, both on the input and the output side? You absolutely need an entrepreneurial spirit, creativity. How can this tech enable new business models, new ways of working? You need skills in AI project management, which is different. It's often more iterative, more experimental. The models evolve continuously. Some level of technical fluency is important for almost everyone, not necessarily coding deep neural nets, but understanding the basic concepts, limitations, those trade-offs like accuracy versus interpretability we just talked about. Communication skills are huge. That data evangelization piece we mentioned. Translating business problems into something data scientists can tackle.
Persuading colleagues and leaders to trust and use data-driven insights. Business acumen remains critical. Can you build a clear business case? Can you connect the AI project back to tangible value, ideally per decision? And finally, this idea of continuous assessment and auditing. You have to treat AI systems almost like a regulator would. Monitor their performance constantly, watch for unintended consequences, drift in accuracy. The phrase, "you hire AI, you don't buy AI," captures it well. It's not a one-off purchase. It's an ongoing relationship that needs management and oversight.
That's a fantastic summary of the skills needed. It really paints a picture of a multidisciplinary future. We've journeyed pretty far today, haven't we? From demystifying what AI actually is under the hood to exploring its power for prediction, its limits, how we can establish causation, and how businesses can actually transform. It's clear it's more than just tech.
It really is. And perhaps the final thought to leave people with is this. The biggest challenge, but also the biggest opportunity, maybe isn't just building smarter and smarter machines. It's about fundamentally rethinking the partnership. How do we best combine our intelligence, our creativity, our ethics with the analytical power of machines? That's where the truly new forms of decision-making, the new sources of value, are likely to emerge. The landscape is changing so fast. So the real question for you listening is, how will you commit to continuously learning, adapting, and exploring this evolving relationship between human and artificial intelligence in your own world?